So another application that you can have here is finding the angles between something. So it's just to remember the relationship that because we're finding the gradient, and gradient is rise over run, i.e. tan. So it just, if we just equate the gradient, so when we find the gradient by subbing in values into the function, we'll get m, and then we can just equate that to tan, and then from that, what we'll actually get is just the gradient of the function, which will kind of make our life easier, right? So we can just find it from there. Alright, so this one, find the angle from the positive direction of the x-axis to the tangent. Remember, it is always the angle from the positive direction of the x-axis. So whenever you find an angle, whenever you do a tangent, always from the positive direction of the x-axis. That's because the unit circle, remember, goes that way. Alright, so at -1, and you can see measured in anti-clockwise direction because of the unit circle. So f dash of -1 is going to be equivalent to -1 over root 1 minus 2 times -1, right? So that's going to be -1 over root 1 plus 3. 1 plus 2. Got ahead of myself. So that's -1 over root 3. Now, we're going to equate that to tan theta. And if we draw our little triangle here, we have root 3, we have 1, and we have 2. If we want 1 over root 3, that's going to equal to our pi and 6 because we want kind of our opposite over our adjacent. And it's going to be negative as well, which means that it has to be in this quadrant, right? Because we're talking about angles up to 180. And this is, I guess, a special circumstance where you use degrees. I feel like this is used more commonly here. So it's going to be in this quadrant, and it's going to be pi and 6, or otherwise known as 30 degrees. Therefore, this angle should be 120 degrees, right? So we're going to say theta is therefore going to be 120 degrees. Cool. All right. So then what we can kind of do here is we want to consider what else we want to do. Oh, sorry, not 120 degrees. What am I talking about? That's pi on. This is 30 degrees, so 150 degrees. Sorry, because it's pi on 3, meaning pi on 6, not pi on 3. So it's 150 degrees. So then what we can kind of consider here is so it will be essentially just be if we pretend that was a function, right? At that point, the gradient of the tangent would be going like this. So we'd have an angle kind of coming from there. Alright, in terms of angles between lines, you can use this compound angle formula used in Spec. Alternatively, you can also just look at the picture as well, but this formula is helpful. So it's m1 minus m2 plus m1, m2. Cool. So if we try and find the acute angle between these two lines, so we'll have 1/3, which kind of passes through here, right? And then we'll have 2x -1. So, no, sorry, that should be going up. So it should be going, so we'll have 1/3, so it'll kind of be 1/3, 3, and it'll kind of vaguely look like this, and then we'll have 2x and -1. We'll have something looking more like this. That's probably not very to scale, but so they're essentially asking us to find the angle here, right? And we know we can find the angle here and the angle here. So if we look at this, we can either find these angles separately and then kind of use that, or we can use the formula from before. So if we use the formula from before, so tan theta would equal to so it was equivalent to m1 minus m2. So it kind of doesn't, I would say it doesn't really matter which one you consider m1 and m2, because eventually you are going to end up with the same angle. But I guess you can kind of tell, so if you end up with an obtuse angle here, you kind of just do have to use logic to which angle you really pick. So I would say we have to try and keep it positive, especially if we're trying to find, so it tells you it finds the acute angle. So like you can kind of use your logic here. I'm going to go with 2 minus 1/3 just because I think that's going to give me my positive result. So then it's 1 minus my m1 times my m2. So that's going to just be, 1 plus my m1 plus my m2. So what I'm going to get here is that it's just going to be that it's 2 times 1/3. So that's going to equal to 2/3 over 5/3, right? So alternatively, that's going to equal to 2 over 5. So my theta is just going to equal to tan inverse 2 over 5, right? So this formula can be really useful in that matter.